actually bringing people back? PostHog answers all of that. We'll integrate their React Native SDK and use it as our single tool for understanding user behavior. You'll set up event tracking to see which subscriptions users add most, funnel analysis to measure how many users complete onboarding, feature flags to roll out new features to only a percentage of users before going live, and error tracking to catch crashes the moment they happen. PostHog also gives you session replay on mobile, so you can literally watch how a user navigates your app and see exactly where they get stuck. And if you want direct feedback, you can trigger in-app surveys after key moments, like asking users what subscription service they wish you supported. PostHog's free tier is generous, more than enough for what we're building. So create your account from the link in the description so it's ready when we get to the analytics section. And we'll also use CodeRabbit for AI-powered code reviews. When you push code to GitHub, CodeRabbit automatically reviews every pull request. It reads the diff, understands the context of your entire code base, and leaves line-by-line feedback, security issues, edge cases, and things that are easy to miss when you're building fast. But it doesn't just tell you what's wrong. It also suggests fixes you can apply with one click, right from the PR. Think of it as having a senior engineer reviewing every commit, except it's instant. And another huge part I love about CodeRabbit, but they don't even advertise it as a feature, is that you can learn so much from it. For our project, you'll connect CodeRabbit to your GitHub repo and see it in action as we build Recurly. And as you're building this React Native application, it'll actually provide you with advice on how you can improve your code base, write more quality code, and just understand the React Native and features you're implementing much more deeply on a fundamental level. It's a 2-click setup, free for open source, and has a free tier for private repos. Same as others, create your account right now with a link in the description. So here's the full picture. Expo and EAS handle your development and deployment. Clerk handles auth and billing. PostHog handles analytics and experimentation, and CodeRabbit handles code quality. That's a production stack. The same categories of tools that the biggest companies use to ship their mobile apps. And every single one of them is free for you to start with today. But before we plug any of these in, you need to understand React Native itself. How the components work, how styling works, how routing works, because that's the foundation everything else builds on. So let's dive into the crash course. All right, let's jump right in. We've already talked about the benefits and drawbacks of React Native and how Expo can make your life easier. Now it's time to dive into the code and see how it works. If you worked with React.js before, you'll find that React Native uses a similar syntax. But of course, there are some differences you should be aware of. So let me show you the ins and outs of React Native code. We can check out how it looks and how it functions when compared to React.js to help you understand the similarities, but also the differences between the two. So super quickly, you'll understand React Native's components and how to use them. When coding in React Native, you use JavaScript, just like with React. But instead of rendering HTML elements, you'll be rendering native mobile components. Take a look at this basic React Native component. Here, we're importing two important components from React Native library, view and text. Then we create a functional component called app that returns the text component wrapped inside of a view. What's interesting here is that we're using JSX syntax, which makes it super easy to create and visualize our components in a more HTML-like way. But if you take a closer look, you can quickly see that this is neither a P tag nor an H tag, nor anything that we're used to while writing code that runs in the browser. In React Native, we use text instead. It's pretty straightforward. The text component is used to display text in the app, and you can style it using the same CSS-like syntax as in React. You can set the font size, color, and weight using the style prop. React Native also offers a styles sheet utility that allows you to define styles by creating a single JavaScript object. This is super handy in larger applications as it optimizes performance. But as we all know, Tailwind CSS is rising in popularity. So in React Native world, Nativewind came into the picture, allowing you to write Tailwind-like CSS styles in React Native. Isn't this crazy? It feels like you're writing a regular web app, but instead you're developing apps for mobile. Now, let's talk a bit about the view component. Think of it as a box or container that holds other components. Similar to the div element in HTML, but with some added functionality specific to mobile apps. The view component is often used to create layout structures for other components. It has many different props that can be used to control its appearance and behavior. And one thing to note is that the view component uses Flexbox layout by default, which makes it really easy to control how its children components are laid out. So you can use Flexbox properties like flex direction, justify content, and align items to achieve any layout you want. But what if you want to add some interactivity to your React Native apps? Well, get excited because there are some amazing components that do just that. Components for creating buttons, links, and other interactive elements. The first one on the list is touchable opacity, which is great if you want to create a simple button. Think of it like a cousin to a React button component, but with even more room for customization. And instead of an on-click, in React Native, you're not clicking it, you're pressing it. So let's provide an on-press. The second similar component is called a touchable highlight, which allows views to respond to touch in a unique way. When touched, the component reduces the opacity of the wrapped div, revealing the underlying color. And then there's the touchable without feedback, which is there if you need to create an element that is clickable, but you don't want it to have any visual feedback when pressed. It is super useful when creating links or images that don't need any additional effects. And apart from these touchable components, there's also Activity Indicator, which allows you to show a spinner or a loading indicator within your app. Sure, there's also a simple button allowing you to set properties like the title, color, and an on press that is called when the button is pressed. But whenever you need some more advanced styling or behavior, you'll find yourself using the touchable components much more often as they offer greater flexibility. Now, the next super important component on the list of components I want to teach you right now, and which we'll use later on within our app, is called a flat list. A flat list is perfect for rendering long lists of items that need to be scrolled. It's like the map function in React, but with some extra features like optimized scroll performance and item separation. The way it works is you, of course, import it from React Native, and then you define some data, such as an array of objects you want to map over. Then you put it all in a view, and you call it flat list. A flat list by default already accepts some props, such as the data prop, to which you can pass an array of data you want to map over, and then a render item prop, which allows you to define exactly how you want to represent each item in the array. Pretty cool, right? Now, when should you use a flat list, and when should you just map over the elements? Well, for larger lists where you want to have smooth scrolling, go for the flat list. While for the smaller lists, the map function will do the job. There's also something known as a scroll view. You can think of it like a magic box that can hold multiple components and views, providing you a scrolling container for them. It's like the overflow scroll property of a div in HTML, allowing you to easily navigate through a list of items or large amounts of content in our app. You can put it within a view, call it scroll view, and then render some elements within it. By using the scroll view component, you can make sure that users can easily explore all the content, making your app more intuitive. And there's also a component which you'll find yourself using super often called Safe Area View, which gives you some sort of a safe zone to render your app's content within without it being covered by the device's hardware features like the notch, home indicator, or a status bar. It's great for building apps that are supported on different devices with different screen sizes and shapes. The way you use it is whenever you think something might be too long or awkwardly placed, you just wrap it within a safe area view. And while that default safe area view is amazing for most cases, sometimes it does fall short for some devices, making it not the optimal choice. So I often like to use a package called React Native Safe Area Context, which works across all devices, even for the bottom bar. But you don't have to worry about remembering all of that right now. I'll show it to you once you start developing your own first app. But bear with me for a moment. I first want you to know which components exist so we can later on use them more easily. For example, we'll surely have to display some images within our app, right? So how can we do that in React Native? Well, thankfully, once again, it is super similar to how it looks like in React. You just use the image component provided by React Native, you pass the source to it, which can be a path or a URL, and you're good. But if you want to display an image as a background, then you should use the image background component, which works in the same way, but just renders it as a background. It's specifically designed to allow other components to be layered on top of it, whereas just the image is used for displaying images on their own. And both of these can handle different image formats like PNGs, JPEGs, GIFs, and WebPs, but none support SVG files because of some native rendering limitations. So if you want to use SVGs, there's a third-party package called React Native SVG. Once again, don't try to remember it. I'll show it to you once again later on so you can use it within your own code. Okay, now that you know how to use images, what about modals? Well, thankfully, React Native has components for that too. It's called a modal. Just import it from React Native, set visible to true, add an animation type, and define what happens when you close it. Pretty simple. There's also an alert component, which you can, again, just very conveniently import from React Native and call it by saying alert.alert, provide a title and functions which you want to execute on cancel or on OK. And if you're creating forms, you might want to create some kind of a toggle in React Native. And for that, you can use a switch component. Once again, it is super simple. Import it, create a state for it, same as in React, create a function that manages it, and then simply call it like this within your code, provide some colors, its value, and what happens when you click it. There's also a component that I use super often called the status bar. Both React Native and Expo have their own versions that allow you to control how status bar should look like for each screen within the app. I prefer using the one from Expo. You can define a view with some text, and just beneath it, you can define a status bar. But what am I even trying to do? I'm just listing all of the different components that you can use to build your mobile applications. Well, I guess I'm just trying to show you that there are some differences, like P tags and H tags are now becoming text, divs are becoming views, but other than that, there are so many components that feel like you're writing React code within React Native, allowing you to build mobile applications. From touchable opacities for buttons, to modals, alerts, and more, the list doesn't stop there. Of course, I don't want to waste your time. We're not going to go through every single component that exists in this video, but I did take some time and I wrote down the most important ones within the free React Native guide linked in the description. So if you want to check them out there, see the differences and similarities, and just have a place where you can recap what you learned, that guide is what you need. But now that you know the most important components and concepts in React Native, let's dive right into action. I'll show you how to set up your app, what files and folders are involved, and everything else that matters, step by step.
Big dreams start small. From getting your domain, to creating your website, email, and online security, we've got you covered. You don't need to be a tech expert. You just need a starting point. Your brand starts here with GoDaddy.
All right, you've got the fundamentals down. You understand how React Native works, how Expo simplifies everything, and what tools we're using to make this production ready. Now it's time to build Recurly. And I'm not just going to show you how to build this one app. I'm going to teach you the full workflow from an empty folder to a published app on the App Store so that you can use this process for any mobile application you want to build in the future. Once you understand this, you can ship anything. So let's start at the main source, reactnative.dev. This is the official React Native documentation maintained by Meta. Head over to Get Started, and you'll see something important right at the top. React Native allows developers who know React to create native apps. And then it says, We believe that the best way to experience React Native is through a framework. And then you can also use React Native without a framework. However, we found that most developers benefit from using a React Native framework like Expo. That's the React Native team telling you directly, use Expo. It provides file-based routing, high-quality libraries, and plugins that let you modify native code without managing native files yourself. So that's exactly what we'll do. Head over to expo.dev. Expo is a full-stack React Native framework with cloud services that cover every stage of the app cycle: development, deployment, monitoring, and everything. Take a look at who's using it in production. There's Discord, Coinbase, Xbox, Burger King, and hundreds more. These aren't side projects. These are apps serving millions of users. It gives you tons of production-ready libraries, camera, push notifications, biometrics, all tested across both platforms, so you don't have to fight with native modules. The developer experience here is built around speed. You develop directly on your phone using Expo Go. You can launch emulators without opening Android Studio or Xcode. Still, I'll teach you how to do that later on, as it's needed to actually put this project up on both the app stores. So before we write any code, let's get your Expo account set up. Click Get Started for free and create your account. It's completely free with no credit card required. Once you've set it up, we can create a new starter project, which will lead us to the instructions on how to do that. But you don't have to follow the steps here, at least not right now, because I'm gonna walk you through the entire process step by step, starting all the way from creating an empty folder on your desktop and opening it up within your IDE of choice. In this case, I'll be using WebStorm. So simply drag and drop that empty folder in, and we are ready to get started. If you want to follow along and see exactly what I'm seeing, I would recommend that you also download WebStorm as your IDE, as of recently, it became completely free for non-commercial use, which means that you're getting a professional JavaScript and TypeScript IDE, well, for free. And with it, you can also set up Junie, your smart coding agent. We'll use it throughout this course to speed up our development. Not the fundamental parts where I want to teach you a lot of stuff about how React Native works, but the repetitive stuff, the stuff that just takes time and is boring to implement anyways. So you can go ahead and set up WebStorm and Junie right away. Once you're within your text editor or IDE, you can open up your integrated terminal, and let's create our Expo application by running npx create-expo-app add latest --template, and we're going to use default at SDK-54. Now, why 54 when 55 is already out, and Expo is going to add incremental upgrades to 56, 7, 8, and so on? While these upgrades are useful and they bring in some new features, what I care more about is for you to have the best experience following along with this course. I want you to learn as much as possible without running into any kind of version-related obstacles. So follow along like this, and then you can easily upgrade once you build the application. And then add the / at the end to create the app within the current folder. Press enter. It'll ask you whether you want to install the Create Expo app installer, so press Y to install it, and it'll download and extract the project files and start setting up the project structure for you. So let's wait until it finishes, In less than a minute, our project is ready, and you can run either one of these three commands to run the project, or you can head back over to the Expo website where we started a new project, and here you can see the second step, and that is to download the Expo Go application. And only after we have it, we'll run npx expo start, allowing us to scan the QR code and connect to our computer. So this is a great point for me to display my device right here on the right side. So at any point in time later on throughout this course, you can see what I'm seeing directly on the phone that I'm holding in my hand. First things first, scan this QR code and download the XPogo application for your phone. Then, back within the terminal, run npx expo start. This will fire up a Metro bundler. It'll give you some kind of a QR code right here, and also additional options and shortcuts you can press. You can press the letter A to open an Android Studio, I for iOS Simulator, R to reload, J to open up the debugger, and we'll use a few of these later throughout the build. But like I said, you don't need Android Studio or Xcode to get started, because the easiest way to develop is with XPogo on your phone. So once you download it, if you're on iOS, head over to the camera app and simply scan the QR code and press Open in XPogo. This will immediately run your application directly on your phone. And you can see it right here. This is the developer menu. You can shake your device or long press anywhere on the screen with 3 fingers to go back to it at any point in time. And then you can see all the additional settings. So once again, if you want to visit it, just shake your phone in your hand, literally, or press and hold with 3 fingers, and it'll open up. And that's it. We have a fully functional mobile app running on our phone in a couple of seconds. If you're on Android, you'll have to scan the QR code directly from the XPogo app. And if you're on the iOS and it's not connecting, make sure that you're on the same network as your computer and that your VPN in settings is turned off. So go to Settings, search for VPN, and make sure that it says Not Connected. And also make sure that you're connected to the same Wi-Fi network as your computer. And if you do that, it should all work. And what you have here is your first React Native app running on a real device, which took about 2 minutes. But now, let's understand what Expo generated for us. I'll go from top to bottom and cover the most important file. First, we have the package.json, which is your project's manifest. The key line here is the main part where it says Expo router entry. This tells Expo to boot the app through the Expo router's file-based routing instead of manually written app.tsx. Then you have your scripts right here, starting with the start script. Then you have scripts for Android, iOS, web, lint, and finally the reset project script, which we'll use in a moment. Then there's the app.json file, which is Expo's configuration file. It controls your app name, icon, splash screen, orientation, and also platform-specific settings for iOS and Android. We'll come back to this later on when we configure our app assets and set up EAS for deployment. For now, you just need to know what it does. There's also the tsconfig.json file, right here at the bottom. This one extends the Expo's base TypeScript config. And 2 things matter here. Strict is enabled, which catches more bugs at compile time, and the path aliases that we set so that we can import with // instead of using the full relative path like .. and so on. So this is going to be super handy. Then there's the package log.json, which logs exact dependency version, .getignore, which keeps node modules, Expo cache, and build artifacts out of the version control. There's also the scripts folder, which has utility scripts within them, the assets folder, which holds your images, icons, splash screens, and fonts. And now we dive to the most important parts. The real code lives within your app folder. Within it, you can see all of the different routes. First, there's the _layout file, which is the root layout that wraps all of your screens. Right now, the only thing it does is it renders the tab navigation with 2 tabs that you can see at the bottom, which changes the screen. Then there's the index.tsx, which is the first thing users see when they go to the / route. There's also the second page, which is the explore page, if you click it on the tab navigation at the bottom. And also, under components, you'll be able to see all the components and reusable pieces of UI, like the animated pieces of text, scroll views, and more. But that's a lot of starter code that we don't need. We're building things from scratch. So let's clean the house. Open up your terminal, and I'll actually open up a second one. This one I'll call Expo, and a new one, which I'll call simply terminal. And within it, I'll run npm run reset project, which is one of the scripts within our package.json that Expo created for us. This script will ask you whether you want to remove the existing code or you want to move it to an example folder instead. I'll simply move it so you can refer to it later on by pressing Y. Expo Go would now like to access your motion and fitness activity, which I'll give it access to, and the project is reset. Existing code, or you want to move it to an example folder instead. I'll simply move it so you can refer to it later on by pressing Y. Expo Go would now like to access your motion and fitness activity, which I'll give it access to, and the project is reset. The next steps are to rerun the npx expo start. So I'll simply stop it from running in the initial terminal by pressing pressing Control C, and then run npx expo start. This will simply restart it. And again, on your phone, you can hold it with 3 fingers. Fingers at the same time, and then tap reload. As soon as you do that, you'll see that now we have a fully empty version of our application that simply says edit the app index.tsx to edit this screen, and there is absolutely nothing else here. So this is our starting point. And everything we build from here is Recurly, your full stack subscription management application.
Hi there, I'm Katya Kovalenko.
Next, let's set up styling. We're using Nativewind, which lets you write Tailwind CSS classes directly in React Native. So if you've used Tailwind on the web, you already know how to style mobile apps too. Same utility classes and same mental model. So head over to nativewind.dev, and we'll be using the latest version of Nativewind, v5, which uses the latest Tailwind CSS features. It might still be in pre-release by the time you're watching this, but the core principles, the classes, and the workflows are stable. If anything changes, it'll be minor file paths or configs, not the way you write styles. So head over to Get Started, and here you can see the installation steps. But instead of following this v4 version, we're going to switch over to Nativewind v5, which is the latest version. And then you can go to the installation page and follow these steps right here. If we were starting from a new project, you could have automatically Automatically set up a new Expo project with native WinV5, Expo 54, and Tailwind CSS. But since we have an existing project, let's do it step by step. I'll put my terminal right here on the right side so that we can more easily go through the steps. The first step is to install a native Wind, and it's peer dependency. Tailwind CSS, React Native CSS, React Native Reanimated, and React Native Safe Area View. And we can do that either with Expo or through npm. In this case, let's proceed with Expo by running npx expo install and then install all of these additional dependencies, which are essentially going to do the same thing. Simply run npm install and add them. There we go. Now moving on to the second step, which is to set up Tailwind CSS. We'll copy and paste this command. Optionally, we can also install Prettier plugin Tailwind as a dev dependencies so we can format our code. And we need to add Tailwind to our post CSS config. So we need to create a new post css.config.mjs, which I'll do right here. In the root of our application, create a new file called post css.config.mjs. We can automatically add it to Git, and then we can simply copy and paste this block of code within it. We also need to create a globals.css file or global.css and add the following Tailwind directives. We already have the global file. No, I thought we had, but we don't yet. So let's create a new file called global.css and simply paste these 4 lines right into it. From here onward, replace global with the relative path to the CSS file you just created. Okay, so that is this global.css file. Now we need to create or modify our metro config. I don't see that we have that metro config yet, so we can run this command right here. That's going to be npx expo customize metro.config.js to create that file. Soon enough, it'll be generated and we'll be able to modify it. So simply we can replace it with what we can copy over from here in Native Wind. And then we can also import our CSS file within either our app or within our layout. So if you head over into our app layout.tsx, here we're importing everything. So it might be a good idea to just import the @global.css file right here for the styles to take effect. We also need to force Lightning CSS to a specific version in our package.json. So let's copy this, head over into the package.json file, and under overrides, which are going to be at the bottom, or we can add them right here below the dev dependencies. We're going to set the Lightning CSS to 131 as they specify right here. For you, these steps might be a bit different, but it's important that you follow along with exactly what they have. And we are using TypeScript, so we have to create a new file called nativewind-env.d.ts, also at the root of the application. That's going to be nativewind-env.d.ts. And we have to just add this reference right here. This file should not be edited and should be committed with your source code. Finally, we are ready to try it out by copying this updated app.tsx, moving over to our app index.tsx, and replicating everything we had with this new welcome. welcome to native Wind part. It should show how class name props can be used, Tailwind utility classes, color utilities, and also typographies. And if you see the style text centered on a white background, native Wind is working properly. So let's test it out by bringing it right here. Immediately, you'll see that the changes are not yet applied, which is fine. That means that we have to restart our application. So I will simply press the letter R to do a manual reload first, and then we'll get a little error saying that it cannot find the global.css file. So let's just fix this path by pointing to @/global.css and then run R to reload one more time. And now we can see welcome to native Wind. Although the styles are not applied, this text isn't centered in the middle of the view, and we don't have a background or a blue text. So what I'm going to do instead is stop the server by pressing Command-C and then rerun it again with npx expo start, and then press the letter R in the terminal to rerun it one more time. This issue is most likely connected to, yep, I think I found it. Lightning CSS, which is one of those version mismatches that the docs warned us about. We added this override for it right here within package.json at the bottom, but we never reinstalled after adding it. The override only takes effect on a fresh install. reinstall. So what we need to do is delete the node modules as well as the package lock.json and then reinstall. I'll do that by opening up the second terminal and running rm-rf, which means delete folder and file, node modules and package lock.json. Or you can delete them by right-clicking and then clicking delete. Once that is done, simply run npm install one more time to reinstall our dependencies. Let's let that run. And after that is done, simply head back over to Expo, stop it from running, and run npx expo start with a -- clear flag, which will restart Metro with a clear cache. And then press enter, and then finally the letter R to reload the app. As soon as it rebuilds it, you'll be able to see a blank screen with a center text that says welcome to native wind, exactly as we expected. Now, currently, we have a blank slate and we can use all of these Tailwind utilities classes, which already makes the development of this app so much simpler because we don't have to have separate CSS files and so on.